How's it going, everyone? In today's video, we're going to be learning about the basics of generics in Python. And for those of you who don't know what generics are a way to write code that works with multiple types while maintaining type consistency. So let's take a look at a few examples on how generics work in Python. Also, small disclaimer, the syntax I'm going to be using in this video is only available as of Python 3.12 for generics. If you are running an older version of Python, you're going to have to look into something called a type var, which you can import from the typing module. And it looks like this. Anyway, for our first example, we're going to create a function that grabs the first element of any sequence. And a sequence is basically any ordered collection that can be indexed. We start by specifying in square brackets that we have a generic type that we want to use. In this example, we're going to use T, which is a common naming convention that is used for defining generic types in programming. But you can use any letter you want, really. I recommend you stick to T though until you become more experienced with generics. Then we will tell Python that we want this to accept a collection of that type. So here we can type in collection, which will be a sequence, which we need to import from collections.abc of type T. And that it should return an element of the type that the sequence contains. So here we will return T. Next, we're going to return a collection at the index of 0. And this allows us to work with literally any type we want while maintaining type safety. Although we're not really going to see the effects of it outside of the function definition in this example. Right now, just to quickly demonstrate how this function works, we're going to create a list of people, which will be of type string, and that's going to equal Bob, James, and Sandra. And the first person will equal get first, and we will insert the people so that we can later print it. And what we should get as an output is Bob, because Bob is the first element in this collection. So what's happening here is that we inserted a sequence of type string. So T was inferred to be a string, which means when we return an element, it must also be of type string. Whatever type we insert is what type we will get as an output. And that's what we're telling Python here. But you might be asking, why don't we just use the any type here? And we can try that. We can type in any, import it from the typing module, and return any. The problem with this approach is that we aren't telling the static type checker anything useful, meaning we can return literally anything here without getting any feedback from the code editor or from the static type checker. For example, if we were to insert 10, this would work. Or we could also return a string, and this would work. We're not getting anything back useful from the type checker. But let's take a look at a different example that uses multiple generics. Here we're going to define a function called getID. And this is going to grab a user ID based on the user we provide as an argument. But this time we're going to use multiple generics. So K and V for key and value. And this is going to take a database of type dictionary with a key and a value as the types, and a user which must be the type of the key. And this will return the type of the value. Then we will return db user. So both of these are types. And again, you can rename this to whatever you want. It could be A and B if that's what you want, but I prefer to give it a meaningful name such as K and V. This is the type of the key, and this is the type of the value. So what we're saying here is whatever type we insert as the key must be of this type. So if we insert K as a key, the user must be of type K. And for the value, if we insert an integer as the value, what we return must be an integer. So let's insert a database, or I don't know, a sample database, which is going to contain the following users, Bob, James, and Sandra. As you can see, this dictionary is of type string to integer. So K is now treated as a string and V is treated as an integer, or at least when we use it. So here we'll type in value of type integer equals getID. We'll pass in the users and the user we want to search for, Bob. As soon as we insert these users, K and V are treated as strings and integers. So what we really have here is a dictionary of type string and integer, a user, which must be of type string now, and a value, which must return an integer. That's what these generic types now contain. So if we go back, it's exactly the same thing. But again, what's nice about this generic approach is that we can swap these around, let's say integer to string, and then create a new dictionary that has, I don't know, the ID as the key and the username as the value. And now we can search by the key once again, which is an integer. And since this now returns a string, we must specify that this is of type string. So in this case, since we have the ID as an integer and the username as a string, this becomes an int, the value becomes a string, the key becomes an int, and the value once again becomes a string. The generics take care of that. But going back to what we had earlier, if you try to insert something such as an integer, when you have a dictionary of type string to integer, this is not going to work because the user must be of type k, which is a string in this example. So your static type checker is probably going to complain. Moving on, let's take a look at how we can use generics in classes. In the previous video, I ignored generics completely because it was beyond the scope of the lesson. But this time, I'm going to show you how to annotate your class with a generic type. To get started, we're going to create a class called custom_list of type t. And inside here, we will create an initializer. And this initializer will take one parameter called items, which will be a list of type t. Then we'll type in self.items equals items. Next, let's create a few methods that use this generic type, such as append. And here we're going to type in self and append an item, which is of type t as well. And since this only executes code, I'm going to return none here. Then we can type in self.items.append and pass in the item. Then I'm going to create two more methods, one called getItems and one called remove. All getItems does is return the current items in our list. Then remove tries to remove an item if it exists. So it checks whether an item is in our list, and if it is, it removes it. Otherwise, it does nothing. Next, let's create an object of this custom list type. So here we can type in CL, which stands for custom list, which will be of type custom list. And the type here is going to be of type integer. Then we can create a custom list that contains 1, 2, and 3. Then right below that, we can type in cl.append, and here we can append an integer. And right below that, I'm going to print cl getItems, so we can get the entire list back. And when we run this, what we should get back is 1, 2, 3, and 4, just as we expected. So just to explain real quickly what's going on here, as soon as we create an object of a certain type, t becomes that type. Since we created a custom list of type integer, t became an integer, which means in reality, our class now looks like this. And what's really cool about this is that we can create an object of any type using this custom list class. If we were to leave this as is, we could only use this custom class with integers. But since we said this is of type t, we can literally use it with any type we want. Which means if we were to create a second custom class, and we were to say this is of type string, we can now pass in a and b, and that would work just fine. We did not have to specify that list was of type string or integer. And this really complicates things as well, because that means we need to worry about the type we are appending to our list, the type we're getting from our list, and the type we're removing from our list. We need to handle each case for both string and integer. While with type t, Python knows to treat each one of these as the type we're using in our current list. So in this case, t is an integer, and in this case, t is a string. But let's remove the second example, because what I want to show you next is that you can still append different types to the list. For example, if we type in cl.append a, this is still going to work. And that's because type annotations are not enforced by Python. So they won't prevent your code from running, even if you insert a wrong type. They're just there to help you during development by providing information to your static type checker about what type a type should be, and what's compatible and what's not. And that's why this code will still run. So I always recommend you use a static type checker such as mypy when you are developing scripts in Python. So here we can just type in mypy main.py, and it will tell me exactly what's wrong. On line 17 of my script, I have an incompatible type, string, where we expected an integer. And in a lot of cases, your code editor is going to be smart enough to flag this, but in other cases, a static type checker is always going to be more powerful. And that's why when I'm very serious about the code I write, I also run mypy, just to make sure that everything is typed correctly. But that's really all I wanted to talk about in today's video, so as always, thanks for watching and I'll see you in the next video.